Hi everyone, again welcome to this lecture on the Linux programming and scripting. I hope you are enjoying the class so far. Um, Last week we started with the Perl programming. This is when the course is getting serious in terms of the programming itself. So today we will be continuing the Linux this course on Linux programming, focusing on the Perl. Last week we introduced the basic commands. Actually, we saw how to actually get data from the terminal or like from external input, and then how we can actually manipulate that input and then produce an output, which is like hello world program, and it also gives the username. That's what we saw. And then we also saw the basic data types, the scalar data type, the arrays, and then the associative arrays. Today we will continue that with looking at some more the data types. One of the special types of array called string, and then we'll look at that, and then we will also like start some of the operations using these data structures and how we can build programs. So we will build it little by little. So let's look at some of the string. So string is essentially like it's again an array of characters, but together they have a special meaning, which is they are treated as a single variable. So there is a concept of a matching, which is essentially what it means is whether the two strings are exactly the same. So like in equality of numbers is fairly easy, where you can say like 2 plus 3 equal to 5, and 5 on one hand and then 2 and 3 on the other hand. If you do a addition operation, they are equal, that we can establish. But in a string, how can you establish like whether a string is equal to another particular string? So it's mainly it's what we call as the comparison or matching. And essentially the matching is achieved through this double slashes. As you can see here, basically it's slash string slash. There are a couple of mnemonics here. One is this this dollar underscore. It actually has a special meaning. This one here, which shows here. The dollar underscore refers to the current line. So it's the current line, or essentially the current value basically as to where it is. So here you can see basically like dollar underscore is directly refers to what is the standard in, essentially like so again this particular statement, you can see that it's a compound statement. It basically gets this value into dollar underscore, and then it also does the chop function on it. One thing is basically this dollar underscore, and that some of these variables you don't really need to specify. Actually, like okay, I'm going to operate on that. Perl kind of implicitly assumes that if you don't specify anything, you are referring to dollar underscore. So that's again another reason why, like in this statement, we don't specify dollar underscore equal to or something. Again, pay attention to the two slashes and the string. So in order to match this particular any string with the dollar underscore, we just simply use the string in the middle of two slashes. So here, so the thing is basically if the result is true, then essentially like that path is taken if you are using like an if statement. And again, like you can use this essentially like if the string appears anywhere in that particular line, anywhere in that line again. So the dollar underscore denotes the line, and this particular string, if it happens to be there anywhere within that line, then the result becomes true when you do just the slash string slash. So in this example actually, so here people with the sierraacademy.com in as a URL essentially, like I mean, so you can specify, like I mean, anything basically here, MS students or electrical engineering students dot sierraacademy.com, but as soon as it finds out that sierraacademy.com is there in that particular uh, as a substring of this particular string, then the result becomes yes. So and then if you give any other one, of course the result is no, and so the else path will be taken. So this is a simple matching function. So as we see, basically, like we are slowly becoming more and more now, like okay, we have some data structures, how we can do programming with this data structure. This will be the discussions that we will go forward with, and then we will see like how we can manipulate the data itself using various commands. Regular expression is the other thing that we will be talking about. Actually, this just introduces the regular expression, but we will go into more details later on. So in general, so we saw that basically, like if it is a dollar underscore here, then we use just the slash slash. But in general, like I mean, the variable may not be just the dollar underscore. You will be actually using other variables to do like string matching. So in order to do those string matching, essentially we use this tilde after the equal to, and so equal to tilde means like okay, now match, and then we then build the string and then we can match again. Here you can see that actually I'm also like putting a dollar at the very end. This dollar indicates that that is the end of the line. So or end of the line or end of the variable is where the dollar is. Look at the previous one actually. Here we do a chop as well, basically like that chop actually chops anything white characters after the white characters between the non-white space and the dollar variable. You can think of it that way. So in this case, like I mean, we are doing the chop again here on the dollar URL. So first we are assigning the standard in to the dollar URL. That's the variable, and then we perform a chop. So it removes all the white space characters. So all you are left with is a non-white space character followed by a dollar. So that's why like now when we do a matching essentially, which is now right here, with this tilde, that's the one that is used for matching. Now we can match it, and then basically like this dollar essentially anchors that particular string at the end of the variable. So it looks for this particular thing at the end of the variable. So can anyone tell me like what is for the beginning of the variable? So to go to the beginning, or basically like match from the beginning of the variable, we use a caret. Basically, the caret is essentially in your keyboard. You can look at as the shift 6. Essentially, that's the caret. So we use that for anchoring the beginning of the variable, and the dollar is used to anchor the end of the variable. So essentially the regular expression itself we haven't really introduced in this section, but now we will talk about the regular expression, because the regular expression is one of the key things in Perl which enables it to actually be used by many script writers. So here the dollar name is matched with John. Can anyone tell me like where this John usually comes? So as you can see, basically since the caret is used, actually that the variable is anchored at the beginning. So this John has to be the first 4 characters of the string in order to match. Now we follow it basically with a /b or \b, which is essentially like denotes a blank character or a white space. And in this one actually it's kind of different. Basically we now say that it's John and then /i. The I actually gives us essentially like that is we don't have to match the exact case. So uppercase John, lowercase John, both can become true in this case. So that's another unique thing about Perl. Now here there is even longer thing basically. So here if you notice actually there are two slashes or actually 3 slashes, one here, one here, and one here, and then there is also this S. So this is basically like where we now start substituting a string with another string. In this example, the string HTTP is substituted with the other string, the FTP. So essentially like you can think of this as like from the beginning basically like if there is an HTTP, then we replace that with the variable the string FTP, and again this is um, so this particular command is in fact used very widely like in Perl, that this kind of string matching and then basically like replacement of the strings. Um, so this is another example. Okay, so as I was explaining, so we can use like the various matching. So a simple matching is shown here, where um, the string is matched against or the dollar name is matched against the string John. One thing that I want to highlight is here. Basically, you can see that actually it's matched with the beginning at the beginning of the string. So the dollar name variable is matched from the beginning. So you can think of this as like its anchoring point. So it anchors either in the beginning or at the end. The beginning anchor is this caret, and as we saw in the previous one, the ending anchor or the towards the end, how we do it is with the dollar sign at the end. So so this is a simple matching basically where it just sees whether this is the same or not. So you can use this matching inside conditional statements to see whether we are getting the right value or not. Now the next one is with the \b. Again, this is \b is a character that is used to match a blank character. So the John followed by blank is what is matched at this point. The next one is /i. This is essentially like as I mentioned, like this makes it like case insensitive. In this case, actually, even the j will the case of the j will also be ignored. So this will match um, um, either like lowercase John like this. It will also match J and then uppercase O H N, whichever one. If the case doesn't matter, it just matches just this set of characters. Doesn't have to be like either uppercase or lowercase. Then the next one is essentially like this is we saw basically. This is where we are replacing the character, the HTTP with FTP, and whether it's uppercase HTTP, lowercase HTTP, it doesn't matter because of this I that is at the end. Basically, then we do that directly. And one more, let's look at this one. This is also like a replacement. Can anyone tell me like what is being replaced? So if you look at the difference between this and this, we call it like TR, and this side it's essentially it's S. The S is essentially for a string replacement. So the string replacement essentially means that like we just replace exactly the same string with another string. In this case, the TR stands for the transliteration operator, and TR essentially changes the case. In this example, actually, all the uppercase will be converted into a lowercase. So so it takes the dollar name. So it here actually like it is basically it takes the dollar name, and wherever HTTP is found, it replaces with FTP. In this case, all the characters are used in this translation, and then in this the way that translation works is it takes the uppercase ones and then convert them into lowercase. So if there is already some lowercase, it leaves it as is, but if there's any uppercase, that gets to become a lowercase. So these are some of the examples of how we do string matching, and kind of we are beginning to now talk about regular expressions, which is essentially like a way to represent strings, which then becomes easier for being operated on. So that's the way, like, I mean, you can look at it essentially. Um, and the end character is also like not just so we introduced this I. There are other characters that we can use at the end. For example, we can use G. So here instead of I we can use G. G is essentially it's matching globally. So this probably matches only the first occurrence, but if you put a G, then it matches all the occurrence of John in this particular variable. And then we can also do string matching or matching against multiple lines, which is by using M as a character. And then there are a few more characters which we will study in the future lectures. But they are like a little bit more complicated. And then a couple of things that we haven't really understood yet is now we know exactly how to match the exact string and how to replace some of the strings and also like some of the characters. There are some shorthand notation for various these functions or these patterns. For example, the D represents or backslash D. This will represent a digit basically, which is like anything between 1 or actually like 0 and 9. So a shorthand notation for this is just slash D. There is one character, and then if you add a plus, this becomes like one or more characters. If you put a star instead of a plus, then that becomes 0 or more of that characters. So these are some of the nifty things that we can use for evaluating. And then there is also like a W, which is essentially a backslash W is a letter essentially, like, I mean, which is from A to Z. So and then we also have there are two of them, two different characters. One is slash backslash S, the lowercase s, and then the other one is backslash uppercase s. The lowercase s signifies space character. It is similar to like this the backslash b, which is essentially like I mean used for denoting white space between two words. And then you can have multiple white space by just adding plus sign. And then the uppercase S is a non-white space character, which could be the same thing basically like 0 to 9 or A to Z. Then the uppercase A to Z also, that's also possible, and any other special characters. They're all included in the uppercase S. So with these kind of usage, actually, like now we can build like I mean we can match exactly like some specific things inside a string or inside a line, and then we can actually use that information in processing that data. So I think like I mean this is all like probably it's little bit more than what we wanted to look at the beginning of the lectures, but I think like I mean it will become more and more clear as we go along, because these are the things that we will use to match and find various things essentially. So now let's look at a function definition. We actually used the function in the previous examples. The chop is a function, it's a subroutine. We even though the definition of that is included as part of the Perl standard libraries, but the way the function defined is using this SUB. Okay, now let's look at the functions essentially. So we actually saw a function previously, which is the chop itself. Actually, that's more like a library based function. So it's like a standard function provided by the Perl itself. In general, the function definition starts with the keyword sub. So here you can see the sub, and then the function name itself, which is here it's the print header. We can have like some arguments. Here there are no arguments. If there are arguments, we will give that within the parenthesis. And then we start this the bracket, and then we just specify what exactly is the content of this particular function. So here the content is actually like use print, and then we just say basically what is the content type, um, um, whether it's a text or HTML, and then followed by, I think like this one you are familiar with now, which is the new line character. So it prints a couple of new lines. Um, so essentially, like I mean, this may be a print header information on an HTML page. If you want to print something out, then this particular subroutine actually prints that thing, and then prepares it for the subsequent content to be printed out. And then the call is essentially we just say print header with either this um, the two parentheses, or simply just print header. So we will be dealing with some of these functions and function definitions and function calls in the later section, because the program itself is not fully done if you don't have these things. By the way, we already talked about it in the first class that in Perl there are no there is no main routine which actually will be executed first. Here basically it just works from top down. So the function calls could be anywhere, and you can call that anytime basically. So the other way to specify a function is to specify this particular command called require. This is essentially like I mean that there are functions that are already predefined and kept in the library. So when we specify this require as a beginning at the beginning of the Perl script, then this particular uh, function will be incorporated within your program, or it will be called, so that whenever you use this the function call. Oh, one thing I forgot to mention in the previous one is when we call the whatever the function calls, we also use this ampersand at the beginning. Ampersand in general you can think of it as like an address or whatever. So the ampersand print header is essentially like I mean the main thing how to call a particular function. So here again for the C time we just call with this ampersand C time, and then here the argument is time, and then it prints out the output essentially. So this one you can actually like go to the Perl library and actually look for C time and see what it does. So now let's come to how do we open a file. The opening of a file is achieved through this command open, and then there are two arguments to that. Here you can see that basically. So this is straightforward, which is the file name, and what this is called is file handle. You can think of this as the address of that particular file. So file name, the name itself doesn't mean anything, but once we start, so the name is associated with just this file handle, and then after opening the file, we always refer to it with its file handle. So here essentially the file handle is using this the log essentially, and then basically like we do this greater than and less than. So now can anyone tell me the how do we read input from the terminal essentially? As you must have seen, and basically as we learned in the very beginning of this course, all the utilities, all the resources in the Unix system or the Linux system is all represented as files. So even the terminal is also a file, and that file name is this stdin. So that's why there are standardized, defined, well predefined file handles, the std in, std out, std error, and then there is also like some arg ones essentially, argv and argc. We will learn about that, but think of it this way, right? The std in, std out, they're all like files that gets written out or read in, and then we use the same file handles to read various variables or read into various variables and basically write out. So it's very similar to the same log, and in this case actually we are just opening a custom file with a custom file handle, whereas std in, std out, std err, they are all like predefined and they are given to you already. So a typical construct is this construct, which is like while and then this end. So in this Perl program, essentially, like I mean, once you open a file, for every line, so when we specify that while and then this greater than less than log, this gets line by line. So the first line will be there, and then we can process that first line, and then since this is a while loop, it goes and processes the next line. It reads one line at a time from this particular file. So here the key thing is, like I mean, it just gets the access.log, and then basically it prints out access log and $_. Here the $_ directly is equal to this log. So it's typically you can think of this assignment is like this, basically equal to. So you can, this is the same, you can replace it here. So while and then basically like this, and then do this, yeah, same thing. So the $_ is a special character, as I mentioned earlier. This is denoted to the current line or current variable, whatever is there in the system. There are similar dollar variables. They are called dollar variables. We will be actually learning some of them actually, because they are also like very crucial, and in fact you can manipulate things with these kind of using the dollar variables. For example, how do we read a particular file, so that, so here, like I mean, one thing you notice is actually when we do this this while loop, always it gets one line at a time. How do we change or can we do something to change this to read multiple lines and use something else as a delimiter? So a delimiter is essentially, like I mean, that's how it reads. Essentially it knows that the end of line is basically the $, or essentially the end of line character. So it reads up to the end of line. So now say like I mean we want to read like any like multiple lines, but on a semicolon. The semicolon can come maybe or maybe on a period. Basically, we want to get one sentence at a time from a text file. How do you do that? And then these the sentences can be like spanning multiple lines. The only delimiter on the sentences is the period. So think about that. In fact, that may be one of the exercises that we will ask you to do at some point. There are ways to do it actually, like to change the delimiter from the dollar to something else. And how do we do it? We'll talk about it soon. So now for writing to a file, essentially we use the redirect arrow, essentially, which is the greater than. So we open the file, but if we use this one in front of the file name, then it knows that okay, this file handle like actually it's going to be a write file essentially. So in the previous one, this was like a read only file. We are reading it from the access.log, but now the write file is essentially from myfile.txt. And then essentially whenever we want to write something to the file, we also add the file handle to the command. So if you do just print and then welcome, so that does not print it into the file. But if you do print with this file handle my file and then welcome, now this welcome will go into this more file. So one question I have is if you do just print and welcome, what does it do? Does it write to some place, or how does Perl react? So the short answer is essentially as you know, everything is a file. So when you say like print, basically without any argument, it assumes that that is what you are asking it to do is to write it into the standard out. So it uses the standard out as the file handle and then just writes out as the output. And then finally we have this particular statement, the close, and then the close statement essentially like closes the file. Usually like when the Perl program finishes running, the operating system goes and actually closes all the files that got opened during the operation. But it is a good idea to actually close the file yourself, because sometimes you may be using like multiple files multiple times. You may have to read and write the files, so you will miss out as to whether you really close or not. And for closing any file, we have to give it the correct file handle. Here the my file is the file handle which we need to specify in order to close the file. So we will come to some of the other interesting ways to manipulate the data later on. So now let's look at the data types and basically like or how do we operate on some of this data. So number one is this scalar data. We already saw the scalar variable, but now the data is essentially like these are, it can be numbers or string of characters. So any particular string is also a scalar string. And one thing to note is essentially like as I mentioned earlier, Perl is not a strongly typed language, and there are no integer values internal to Perl. All the numbers are stored as double precision floating point numbers. So again, this is one key difference, so that you can operate integer with a floating point number, and Perl will accept it and then produce a result. There are some rules that you need to follow, which I will explain as we go along. And then the other one is basically the literals or the constants are the way the data is represented in the source code. So all the floating point literals in C are legal in Perl. So these are the things that you want to keep in mind. So what are floating point literals? Some of these examples are 1.234, 1.23 e to the power 45, or minus 6.5 or minus 6.54 e to the power 3, or minus 12 e to the power 34. These are all floating point literals. The integers are essentially like what is shown here. FF could be an integer. Octal 177 is actually an integer with value of 127. Hexadecimal FF is the same as 255. So for the string, the examples basically there are no size limit. It can be from anywhere from 0 to infinity. There are two different types of strings here in Perl. One is the single quoted string and the double quoted string. So the single quote string that we already saw in the examples before, essentially like I mean those are we used some of those things basically like I mean in those examples. The double quoted strings are more common essentially. So the difference here is like how much we can do the operations on. Within a double. So the key difference between the in the double quote string is that you can actually use variable names within the double quote string, and Perl can interpret that as a variable so that it replaces that with the actual variable during the execution or when you're running the program. Whereas in a single quoted string, they're all just taken as a literal string. So essentially, like even if you put a dollar something, it's the same as what it is. So here, essentially, like I mentioned again, the double quoted strings. Essentially, they are strings like exactly like in C. You can use also to you can use the backslash characters for escaping the control characters. And also like I mean they are used as the control characters as well. So you can specify like I mean backslash n. That's one of the things that we saw in earlier ones. Basically backslash n represents the new line character, and then number 7 in ASCII represents the bell sound. Hexadecimal x7. Actually like the F denotes that basically, and then that's actually no sorry, X denotes the hexadecimal, and then the 7F is the character. That's for delete. And another example is this variable interpolation is in double quotes. So and some of these things that we saw basically are new line character, backslash n, the return character, or it's backslash r. CX is essentially control X, which is very common in Emacs kind of editors. Backslash T is tab. Then there's form speed. Some of these things are we hardly use them today. but I think like I mean this is a complete list of all the characters that we can use essentially how we can escape them. So I will let you read some of these things at your leisure. You can think of you can see basically like I mean even like the codes themselves can be escaped, and so it can print out the real ones essentially. So here are some examples. A simple square string with double quotes, just say hello, which just prints the hello. Now don't, it prints just the don't with a single quote within. Then hello world, basically it prints hello world with a new line character, so it goes to the next line. Now a single quote, the single quote is also represented as backslash quote. The backslash itself is represented as the backslash. And then the no other backslash characters are allowed essentially inside the single quote strings. So you can only like escape two things. One is the backslash itself or the quote itself. And then the string should not cross the line boundary. And then there is no variable interpolation. So if you are using like dollar something dollar sentence, it just prints out as dollar sentence. It won't change that to what the equivalent value is. So the dollar variables are just represented as is. There is no interpolation on the variables. And I think like I mean this is probably the biggest difference between a double quoted string and a single quoted string. In a single quote there is no variable interpolation, whereas in a double quote if you add a variable in the middle, they are interpolated and expanded the variable. The values are used when you run the program. So some of the examples like hello. So this is exactly the same as double quoted hello. So there is no difference there. Don't, for don't actually we need to escape the quote. Otherwise the string will end at don't. So if you escape it, then it prints out properly if you don't. And then the hello world, multiple lines essentially like I mean so it prints out with the new line that is added here. And then new line itself is basically it's just a 2-character string, essentially it prints out exactly the same. So one question for you is what does this mean basically? To maybe like more challenging, what does this mean? So $A equal to quote single quote backslash n the colon, and then $B equal to a print $B. So try this program and then see what generates. We will talk about it in the next class as to what exactly that we will see. So I think that's the end of today's class. So we'll see you in the next one. So just to recap, essentially we started talking about some string variables, specifically string matching. How do we match strings? and then we also went through like how to do some of um, the matching itself, like I mean how do we operate on the strings. We studied about a little bit about the regular expression. We haven't really introduced in a big way. I'll try to do that in the next class as to give you like more gory details about the regular expression and how can we do matching on really esoteric um, items um, and you know like I mean the wherever you can find some regularity you should be able to use regular expression and then use a lot of matching. And this matching and this associative arrays are probably two main topics in Perl, which is useful across where you are and which company you work for. Everywhere you go they will all be using these two principles, the associative arrays and the regular expression matching. So we saw that, and then we also now started talking about the strings as to what kind of string that we can build, what is the difference between a single quote and a double quote. Again, the key difference there is the double quote will do the variable enumeration, or actually it will extrapolate all the variables, whereas for a single quote it won't do those the variable interpolation. So I guess that's pretty much currently like I mean what we have, and then we will start talking about how we go about in the next class. Okay, thank you very much.